All right, we're going to begin the next unit, and we're going to start with a little bit of review from Algebra 1 dealing with exponents, because it's all about rational exponents and stuff like that. But trust me, you'll see how crazy stuff gets when we get there. I mean, you probably might be looking at these questions and thinking, you mean that's not crazy? Well, you know, we can massage our way into it. So these are questions that we're going to go over for review to touch on some material that you have to know before we get into really complicated things. And so I have 5 little examples of expressions that deal with exponents so we can get more practice with what's called the laws of exponents. So I'm just going to jump in and work on them, and then we'll come across things as we come across them. So we have example number 1, a little multiplication example, and we're going to take 3x to the 4th power and multiply it by 5x to the 3rd power, and hopefully you can see when you read it out loud that I did say times. That's going to be important because understanding operations and recognizing operations is really the key difference. And in fact, maybe that'll be the first thing that I demonstrate. So have to see the difference between operations and know the rules for them. So if I had an example, when I talk about the difference in operations, I'll give you something like 2 plus x. Right, and I'll say, okay, well, what is 2 plus x? And you would say, whoa, Mr. Katz, you're crazy. We cannot add them. They are not like terms. Okay, so they are not like. We cannot add them. So 2 plus x is 2 plus x. And that's absolutely correct. And then I might turn around and say something like, well, then tell me what is 2 times x? And you might say, well, Mr. Katz, don't be crazy. You can't multiply 2 times x. And I would say, oh, you're the crazy one. You've been multiplying 2 times x since as far as you can remember. So what is 2 times x? 2x. Heck yeah, we can multiply those. Right? So 2 times x we can deal with. 2 plus x we cannot. Make sure that you're able to recognize a difference of operations. That is the first key element in laws of exponents. So when we go back to number 1, we can see when we say the word times, that we are okay to start multiplying everything through. So what this is saying is 3x to the 4th power times negative 5x to the 3rd power. So we're looking at 3x to the 4th power times negative 5x to the 3rd power. Now, what's happening between the 3 and the x to the 4th power and the 5 and the x to the 3rd power? And hopefully you can see, once again, that's multiplication. And right here is also multiplication. So seeing operations and knowing how things works is going to make a whole lot of things easier. And if you know anything from multiplication, remember the commutative property, we can completely rewrite all of this stuff. We can rewrite it as negative 5 times 3 times x to the 4th times x to the 3rd. And then feel free to multiply that through. Okay, so remember, we can't add things that aren't like, but we sure can multiply them. So we are free to start multiplying things. And then we can just get going, right? So we have negative 5 times 3, of course, that's negative 15. But then what's the deal with x to the 4th times x to the 3rd? Now, I'm going to tell you a rule that you can always get away with it. And here's the rule. When in doubt, write it out. When in doubt, write it out. Because I'm going to show you some laws with different letters and stuff, and you may not understand it, or you may have a hard time comprehending it, but when in doubt, write it out. What does that mean? Take a look at x to the 4th times x to the 3rd. What is x to the 4th? It's x times x times x times x. What is x to the 3rd? X times x times x. And what is that going to turn out to be? Well, that's x to the 1st, 2nd, 3rd, 4th, 5th, 6th, 7th power. So this is actually going to turn out to be negative 15 x to the 7th power. And that is what this expression is. Okay, so when in doubt, write it out. But here is the law of exponents that we just exercised. So the first law of exponents I'm demonstrating is this following law. Any 2 numbers that have the same base, okay, 2 numbers being multiplied that have the same base, simply add the exponents. keep the base, add the exponents. That is the first law of exponents that we have just demonstrated. Okay, so if I'm multiplying x to the fourth times x to the third, I keep the base, add the exponents law. That's a law of exponents. And now you don't need to ask, well, why does that work? Because I just showed you that's why. All right, so that's number one. And now we're going to move on to the next example. Number two. Wow, this is a little bit different, isn't it? Well, yes, it is. So we have 4a to the second power, b to the third power, c, all divided by 12. A to the third power, b, c to the second power. Now, there are some interesting things coming here. And I'm going to not show you a law for this one, but I will take a look at some review. Okay, so the first thing we need to review is what I call the big one. The big one. Okay, so if I were to say something like, well, what is, 17 times 1? And of course, you would say, well, 17. Like, well, it's true. It is 17. And I'd say, okay, well, let me ask you another question. Okay, so what if I said, what is, 13 divided by 13? And you would say, well, that's 1. I hope you would say that. Right? So 13 divided by 13 is 1. That's true. I totally agree. So then what you're telling me then is that if I had 17 times 13 divided by 13, that would equal 17, right? I hope so, because it's 17 times 1, which is 17. Very good, very good, very good. Well, what's going on? All right, well, what about 23 times 1? And you would say, well, of course, that's 23. And I'd say, okay, well, hang on. What is x divided by x? And hopefully you can tell me that x divided by x is 1. So you mean to tell me that if I had 23 times x divided by x, that would be 23? And I'd say, well, yes, it is. And then I'd say, well, what if I rewrote this a little differently? What if I took this and then rewrote this as x times 23 divided by x, right? And then you'd have to say, well, that looks a little bit different, but do you see what I call the big 1? Do you see the big 1 there? There's an x divided by an x. That's a big 1. And I'm multiplying that big 1 times 23. And 1 times 23 is 23. Okay, so that's something to remember. You got to look for the big 1. Which brings us to number 2, right? So there's that whole thing. Well, why did he show us that? Well, here's why. Take a look at what's happening here. We can do some simplification in this example. I'll get to, well, let's cover the 4 over 12 first, because that's kind of the easiest one. 4 over 12. If you remember this from elementary school, right? Hopefully you can remember this. 4 divided by 12. 4 over 12 is 1/3. Hopefully you can remember that. Okay, so 4 over 12 is 1/3. Okay, so 4 goes into itself once. 4 goes into 12 3 times. We're left with 1 over 3. So hopefully you can see that that's going to end up being with 1 over 3. Then we can start looking for the big 1. See how we have a squared here and a to the third power here? Remember the law we just went over? No, not that law. The rule. When in doubt, write it out. Let's take a look. When in doubt, write it out. What's a squared? It's a times a. What's a to the third power? A times a times a. Do you see a big 1? Hopefully you see a couple of them, right? A on top, a on the bottom, a on top, a on the bottom. What's left? A on the bottom. And we can do the same thing with the b's, right? So we have b to the third power, and then b on top, b on the bottom, the big 1. And what's left? 2 b's on top. And the same thing with the c's, right? 1 c here, 2 c's there. Okay, so we have c on the top, c on the bottom, the big 1. What do we have left? C on the bottom. So we have all these things that just totally canceled because of this same principle of the big 1. Okay, 13 over 13 is 1, x over x is 1, and we can cancel some stuff out. Excuse me. So when we're looking at this crazy example, look at what's left in the numerator. We have 1, b times b, and then that's it. So we have 1 and then b squared at the top. And then at the bottom, we'd have a 3 and then an A and a C. 3AC. Oh, that's a C, or it should be a C. So we'd be left with B squared over 3AC. And that's how we would simplify number 2. Okay, so remember number 2, the expression was this craziness. And, well, this is what we've had. Now, I will, not that we've used this law, but I'm going to write it out anyway because it's fun, which leads us to another law. Law of exponents. If you had two numbers with the same base and you were dividing them, you would keep the base and subtract the exponent. Keep the base and subtract the exponent. And the only example I'm going to give you for this was that one thing that we did with the b's. Do you remember we had b to the third over b? Right? Isn't that the same thing as b to the 3 minus 1 or b squared? Right? So that was that one example. Boom, blam, boom, bam. There's that law. All right, so that's how we figure number 2. But again, when in doubt, write it out. What about number 3? If you have to write this one out, well, good luck, because you can totally do that too. So number 3, we've got this craziness going on. Okay, so we have 4x to the third power, y to the fourth power, and all that's to the second power. Remember, when in doubt, write it out. But I'm not going to do that. Okay, so what I'm going to do is apply a law. Okay, so there's actually be 2 laws that are being applied here. So when in doubt, write it out. So let's go ahead and, well, you know what, I will do that. Let's write it out. So we have 4x to the third power, y to the fourth power times 4x to the third power, y to the fourth power. And now we're back in a situation where it was just like number 1. Okay, so we have 4 times 4 times x cubed times times y to the fourth times y to the fourth. And then, of course, we get 16 x to the sixth, y to the 8th. Okay, so, but now what we can do is apply 2 different laws of exponents to demonstrate this. Here comes law number 1. Okay, so law. If I have 2 numbers being multiplied, excuse me, raised to a certain power, if I have 2 numbers being multiplied raised to a certain power, what I then can do is apply that exponent to each number. Okay, so I have 2 different numbers being raised to a second power, or raised to a power. I can apply that power to each exponent, and that's exactly what we could have done in number 3. So the first step we could have taken could have been this: we would have 4 to the second power, and then we would have x cubed to the second power, excuse me, and then we would have y to the fourth to the second power. Excuse me. And so we would have that law being applied. And then we would see a second law arising. Law. If I had a to some power being raised to another power, so a power being raised to a power, I could have a to the n times m. Right? That's a neat law to know. But if you can't handle it, just when in doubt, write it out. So I would have 4 to the second power is 16. X to the third power to the second power. You see what's happening there? X to the third to the second, x to the sixth. Y to the fourth to the second, y to the eighth. And that's how the laws of exponents work. Or when in doubt, write it out. Okay, so that's how the laws of exponents works for that example. Moving on. This is going to be a fun one. Check this out. I'm actually going to demonstrate the next 2 laws right here. Okay, so number 4, we've got this crazy looking thing. Now we see negative exponents. And we're like, what is that all about? So we got this crazy looking thing, and we see negative exponents and all sorts of stuff, and we see it's being raised to the 0 power. So let me show you some cool stuff. So we've so far seen a difference of operations, what the big one is. Now we're going to take a look at some cool stuff. Cool stuff. All right, so let's take this example. What if I had 3 to the third power? Do you know what 3 to the third power happens to be? It happens to be 3 times 3 times 3. You know what 3 times 3 times 3 is? It happens to be 27. Now, what is 3 to the second power? 3 to the second power is 3 times 3. Do you happen to know what 3 times 3 is? I know. You just said 9. But do you happen to know what else 3 times 3 is? 3 times 3 happens to be 3 times 3 times 3 divided by 3. Whoa, what? That's right. 3 times 3 happens to be this divided by 3. That's what this is. And remember, the big 1 cancels, and you're left with 9. That's where your 9 came from. I know, isn't that cool? What about 3 to the first power? What's 3 to the first power? It's 3. You know what 3 happens to be? I know. You said 9. 3 happens to be 3 times 3 divided by 3. Whoa. And 3 times 3 divided by 3 is 9. Or is 3. 9. Big 1 there. You're left with 3. So what do you think is going to happen with 3 to the 0 power? Well, what is 3 to the 0 power? I have no idea. But look what was going on, okay? 3 to the first power was actually 3 to the second divided by 3. 3 to the second power was 3 to the third power divided by 3. So what do you think 3 to the first power, or 3 to the 0 power is? It's going to be 3 divided by 3. And 3 divided by 3 is 1. What? That can't be true. Oh, yes, it can. Watch. The same thing happens with 4s. 4 cubed, 64. 4 squared is 64 divided by 4, which is 16. 4 to the first, which is 16 divided by 4, equals 4. 4 to the 0, which is 4 divided by 4, which is 1. Oh, my God. It works there, too. So guess what's happening? Anything to the 0 power is 1. And if anything to the 0 power is 1, we have a law. Law. Anything to the 0 power is 1. Isn't that cool? So look at number 4. Guess what that is? Now, if you want to start using the previous law where you're applying the 0 to every exponent, knock yourself out. But this whole big thing to raise the 0 power is 1. What? That easy. Bam. How cool is that? When in doubt, work it out. All right, so number 5. Last one, and then I'll be done because I'm talking too much. All right, so the last one, now we're getting some crazy stuff. I'm going to show you one more thing, and then we could do this last problem probably about 7 or 8 different ways. But I do want to show you one more thing. So we have this crazy looking expression, and we're going to figure out how to simplify that, right? So let me show you one more thing with the cool stuff, and then we'll finish that. You remember where we were, the last one, where anything to the 0 power is 1, right? And we had 3 to the 0 power is 1, and 4 to the 0 power is 1, and a to the 0 power is 1, and x to the 0 power is 1. Anything? Well, what about, what's going to happen next? Take a look at the 3's. We have 3 to the second, 3 to the third, 3 to the second, 3 to the first, 3 to 0. What comes next? What comes next after that? Guess what comes next after that? 3 to the negative 1. Whoa, what? That's right, 3 to the negative 1. And how would that work? Well, notice what's occurring. What's occurring? In each time that we're taking the next thing, right, it's 27 divided by 3, that's when this is, and then 9 divided by 3, that's what this is, and 3 divided by 3, that's what 1 is. So what do you think this is? It's going to be 1 divided by 3. And what's 1 divided by 3? 1/3. Well, that's weird. So you mean 3 to the negative 1 is 1 over 3? That's right. Huh. Well, what would be next? 3 to the negative 2. Here's where things are going to get weird. How would we find 3 to the negative 2? Well, we're going to take this and divide it by 3. So we have 1/3 and then divided by 3. Cats. I don't want to see any more elementary school math in my algebra class. Yeah, you do. How do we deal with dividing fractions? Remember, we'll keep, change, flip, and all that stuff. So 1/3 divided by 3 is actually 1/3 times 1/3. And we all know 1/3 times 1/3. That's 1/9. Wait a minute. You mean to tell me that 3 to the negative 2 is 1 over 9? Yeah. Take a look at what's happening. 3 to the second power, 3 to the first power, 3 to the 0, 3 to the negative 1, 3 to the negative 2. Take a guess. What's 3 to the negative 3? Positive 1 over 27. Whoa. That's so cool. Does it happen with 4s too? Oh, yeah. Let's take a look. So we have 4 to the third, 4 squared, 4 to the first, 4 to the 0. What about 4 to the negative 1? It's 1 divided by 4, which is 1 over 4. What about 4 to the negative 2? That's 1 over 4 divided by 4, which is 1 over 16. And that's going to bring us to our last law. Law. It's actually kind of two laws. Well, I'm going to write it twice. It's the same law, but it's written twice. Law. A to the negative n is equal to 1 over a to the positive n. Notice how it doesn't make a negative. I'm going to write that down. Doesn't make a negative. Yell at you. Okay? It just puts it into the denominator and makes the exponent positive. Okay? So this simply puts the number into the denominator and makes the exponent positive. On the other side, which is funny because it's a joke, on the other side, what if you had a negative exponent that was already in the denominator? Okay, so what if you had a negative exponent that was in the denominator? Law. Well, 1 over 1 over something puts it back in the numerator. Wait, what did I just say? I said this. If you have a negative exponent in the denominator, it simply moves the term into the numerator. Okay, so it doesn't make it negative. It just simply moves it into the numerator. Okay? Okay, those are all the laws of exponents. And so now, let's take a look at number 5 and do this in any way. There are many different ways to attack this expression. Many ways. You will get to the same result. There are many, many ways. And I'm not going to show them all. I'm going to show just one. You can figure out another way. In fact, I dare you to do it differently than me. Okay, so there's many ways to attack this, as long as we know all the laws. All right, so we have 3 and then a to the second power, b to the third power, c to the 0, all raised to the negative third power, over 3ab. So we could do a bunch of stuff. The first thing we could do, if we want, is to take that negative 3 exponent, move the entire thing into the denominator, and go crazy from there. You can totally do that. I'm not going to. What I'm going to do is this. I'm going to say, well, the next thing we could do, right, I'm going to apply all the exponents into the parentheses. I'm going to raise to the negative second to the negative third. Wait, what? So b to the third to the negative third, and then c to the 0 to the negative third, which is pretty much a waste of the pen right there. And then that's all over 3ab. I haven't touched anything. That's what I'm going to do. Okay. Then what can you do from here? Okay, so from here, so I'm going to do a few things at once, so listen carefully. I have 3 to the negative third. What does that mean? That means I'm going to make this move down there and call it 3 to the positive third. What? That's right, law of exponents, that last law we just learned, right? Anything to the negative power moves it into the denominator, makes the power positive. Doesn't make it a negative 3, it just makes it 3 to the positive 3 in the denominator. Now, that's what I'm going to do first. I'm going to take that, move it down there. Then what am I going to do? I'm going to take this and use that second law of exponents and call that a to the positive 6. It stays up top. Whoa. And then I'm going to multiply this out and call that b to the negative 9. And I'm going to multiply this out and realize, well, that just goes away because anything to the 0 power is 1. So I'm going to make all of these moves. I'm going to make all these moves at once, and this is what I'm going to come up with next. So I have a to the 6th power, b to the negative 9th power. That's all I have left in the numerator. In the denominator, I now have 3 to the positive 3rd power, then times 3ab. All right, so that's next. And again, many different ways. So what can happen now? I'm going to take care of my negative exponent next. So b to the negative 9th moves down. See ya. And that's the only thing I'm going to do next. So I have a to the 6th power up here, 3 to the 4th power times a times b times b to the ninth power. If I need to explain what happened, I will. I have 3 to the third power and another 3. Guess what that means? Because I'm multiplying, right? I'm just multiplying all these through. I'm just multiplying, which is the first thing I showed, 3 to the fourth. Okay, so now it's just a matter of canceling some stuff out and using some last laws. All right, so now I'm going to use the big 1, and then I'm going to put those together, and I'm finally done. A to the 5th power is left at the top. I'll have b to the 10th with my b's. All I got to do now is multiply out, 3 to the 4th power, 81. Blam. And that is the expression. So this crazy looking thing is actually a to the 5th over 81, b to the 10th. Many different ways to approach it. Do your homework. I'm out.